Okay, so an exponential function is a function f of x of the form. So whenever I have like some constant b to the power x, so that will be an exponential function. So where b, so the variable here is x. So the variable x is the exponent, right? So where b is a constant. Is actually, it has to be a positive constant. So b is a positive constant and different from 1. It has to be different from 1 because 1 to the power x would be equal to 1 for any x, and so that will be just the constant function. So different from 1. So this number b, this constant b is called the base of this exponential, different from 1. So b is called the base of f of x, of the exponential function, right? So you have a constant b to the power x, where b is some positive constant different from 1. That's what I call an exponential function, right? I think we discussed some examples yesterday. We discussed some properties of this exponential function and the graph of this exponential function. So for example, just to remind you, so for example, so f of 0 is always equal to 1, right? Because b to the 0 is 1, right? So f of 0 is 1. If you do, for example, f of 1, that would be just b to the power 1, and that will be equal to b, right? Etc. So it's just f of 2, that will be just b squared, which is b times b, right? That's just b times b, etc. Anyway, so that's for an exponential. Now, after the exponential, I try to introduce the logarithmic equation. So the definition of the log or logarithmic equation is that logarithmic function is the inverse of the exponential function, right? Oh yeah, before logarithmic function, let me just say here, guys. So I discussed. So there is this a special number called the number e. Special number called the number e. So this number e, it's some decimal, so it's the number e. It's actually equal to 2.71, etc. Okay, so it's some decimal. And what's special about this number? As I said yesterday, we're gonna see this later, like in Calc 1. So if you take the exponential function with the base equal to e, then the derivative of the exponential function is gonna be equal to itself. Okay, and so the exponential function with base b equal to e, so this is called like the natural exponential. So this is e to the x, e to the x. So this function here, so this is a natural exponential. Exponential. So when this when this constant b is equal to this number e, that's what I call the natural exponential. All right. Okay. Now, now for the logarithmic function. So the logarithmic function is supposed to be the inverse of exponential. Okay. So now. So f of x is equal to b to the x. That's my exponential. This is my exponential function. Exponential function. Now the inverse of f the inverse of f of x is called, so that's, let's say, a function g of x, so is called the log in base b, log, so in base b of x. Okay, so the log by definition is the inverse of the exponential, right? Now, so for example, if you do, so what's exponential of f of 0, f of 0, which is b to the 0, that's, we said that's equal to 1, right? Now, what will be g of 1? Because, so f is the exponential, right? And g is the log, which is the inverse of the exponential. So if f of 0 is 1, then g of 1 would be 0, right? This is equal to 0, right? Because the inverse function would switch the input with the output. So if f of 0 is 1, then the inverse, for the inverse function, g of 1 would be 0. So this is because because g of x is the inverse of f. G of x is the inverse of f. Okay, so if the exponential of 0 is 1, then the log of 1 would be 0. Okay, so what I'm saying here, guys, is that, so whenever you have log in base b of 1, this is always equal to 0. Okay. Now another like special value of log, for exponential, we said like f of 1, that will be equal to b to the power 1, right? The exponential. So that's equal to b. Now, what will be g of b? Because, so g is supposed to be the inverse of f. So what we do is we interchange the output with the input. So if now my input is b, then output here will be 1. Right? Because g is the inverse of f. Because g of x is f inverse. Remember, I mean, we had a couple, I think like in the some homework, we had a problem where, which says like f of 1 is 5, then f inverse of 5 would be 1, right? So you just switch the input with the output. So that's exactly the same thing here, because log is supposed to be the inverse of the exponential. So if exponential of 1 is just equal to b, then the log of b would be equal to 1, right? So that's like another special value of log. So log of, so what we are saying here is that, so g, remember g is, this is the log in base b. So what we are saying is that the log in base b of b, that will be equal to 1. Right? One more thing, I think, which is important, is that, remember, we said for the exponential, so for the exponential function, f of x, so f of x, which is b to the x, because b is always positive, then this b to the power x is also positive. And this is always positive. Right? The exponential, the range of the exponential function is just positive numbers, because the b is supposed to be positive. So if remember, for the log is the inverse of the exponential. So if all the outputs of the exponential are positive, then the inputs of the log, they must be positive. So then log in base b of x is only defined for positive x. Positive x. So if you have a log of something, log of log of x, then x must be positive. Okay, it's like saying like for the square root, we cannot have like a negative number in the square root. So same thing here for the log. So inside the log, you cannot have like negative or zero. Okay, so for positive x. Okay. So what we are saying here is that, so inside the log, so log in base b is only applied on positive numbers. Okay. So in other words, what I'm saying here is that, for example, so log in base b of negative 4, this number here do not exist. Okay, or log in base b of 0 do not exist. Okay, etc. Or log in base b of negative, let's say 1/2. Well, it's a negative fraction, but it doesn't matter if it's a fraction or a whole number. It's negative, so then the log do not exist. Okay. What else? Yeah. So what you have to keep in mind, this is kind of like some properties we're gonna use later. So like log of 1 is always 0, right? So this is like a first, this first value here. So if you have a log of 1, log of 1 is always 0. It doesn't matter the base b. Log of 1 is always 0. Log of b in the base b is 1. So if you have a log of some number in the same base, then the answer would be 1. Okay. And what you have to keep in mind is that the log is only defined for positive numbers. Okay? You cannot have a negative number or 0 inside the log. Oh yeah, and the last thing, guys, before moving to the log and exponential equations, when this base b is equal to this number e, this is special number e, then the log is called the natural log. So right here. So when the base b is equal to this number e, again this number e is this 2.71 something. Okay, so it's some decimal. Then the log in base e of x is actually denoted by natural log ln of x. Okay, so this is called the natural log. Natural log. So ln stands for natural log. This is natural log. Okay. Because this exponential e, I mean this number e, as I said, e to the x, that's like the natural exponential. So when the base b is equal to this number e, that's what I call natural log. All right, and then of course we saw a couple of properties of the log. So just to remind you some of these properties, because I guess we're gonna use them later. So first property is that, as I said, well, log of 1 is always 0, right? Second property is that log of b in base b is 1. So log of b in base b is 1. Next. Now, when we have a log of a product, So if you have like a log of x times y in base b, that will be the sum of the logs. So that's the log in base b of x plus the log in base b of y. Okay. So I mean, this is again, this is true because the log is the inverse of the exponential, right? So exponential of the sum is the product of the exponential. So because log is the inverse, then the log of the product is the sum of the logs. Okay, in some sense, it's like you reverse, you know, the product and the sum. Anyway, so I think we discussed a little bit this property yesterday, and then when you have a log of division, so when you divide x by y, so log of x over y, this is actually log of x minus a log of y, right? So so it's like so when you divide, then you take the difference between the logs. And the last property, which is kind of important, so if you have a log of some power of x, then you can always log in base b of x to the some power a. Okay, a is just some number. Then you can actually put down this number a in front of the log. So you can move this a here in front of the log. So you're gonna have like a times log in base b of x. And as I said, guys, I know this is like a common mistake. So when I say like log, so when I say like log in base 3 of 4, first, this is not multiplication. I'm not multiplying log by 4. Okay, this is not a multiplication. This space here, this is off, log off 4. Okay, so it's like you're applying log to the number 4, and this log to the log of 4 in base 3, it's just some number. Okay, if you use your calculator, you know, you can figure out what's this number. Okay, so this is just some number, probably decimal. So of course, this number here, it depends on the base. So of course, if you change the base, so it's like if you take log in base 4, that would be equal to 1, for example. Okay, log in base 3 or 4, that would be a different number. Okay, so when you change the base, of course, you're going to change like the answer, right? Yeah, so I mean, you cannot. So again, you cannot separate the log from the log in base 3 from the 4. So the log in base 3 of 4, they come together. Okay, you cannot separate them. All right. Is there any question, guys, before moving to the log and exponential equations? So this is like basically what we did yesterday. I think we had like a couple of exercises about these properties. But now, next, we're going to solve some equations. So that's where we're going to use all these properties. So you may ask, is this useful? I mean, all these properties, are they useful? You'll see in a couple of minutes how we use these properties to solve some equations. All right, so let's move to the equations. So solving log and exponential equations. Okay. So let me start with the log. Let's start with the log. Okay. So first, let's start with the log because I know log is kind of, I would say it's harder than the exponential equations. So let's start with the log. Okay. So I'm going to give you an example. First, like a very simple equation. So first equation, let's say you want to solve, so log in base, let's say For example, log in base 2 of 8 equal to x. Okay, and of course, we want to find x, right? We want to find x. Find x. So this is x is equal to this log in base 2 of 8. So actually there are different ways to solve this kind of logarithmic equation. So I would say the general way to solve logarithmic equations is to apply the exponential. So so what we can do is the following. So the idea is to get rid of the log always. Of the log, right? So you have some equation with the log. I mean, the log really looks like ugly, right? So you want to get rid of the log, right? And the way to get rid of the log is to use the exponential, because exponential and log, they are inverse of each other. So it's kind of, when you apply the exponential, the log and the exponential, they would cancel out. Okay, so here I have this log in base 2. Right, this is my base is 2, right? So what I'm going to do, we're going to apply. So by applying, so we get rid of the log by applying exponential in the same base to both sides. The same base to both sides. All right, so exponential. Again, what's exponential, guys? It's remember, exponential was like b to the power x, right? Where b is the base. Here, my base is 2, right? So it's gonna be like 2 to some power, right? So here, 2 to some power. Now, the power would be like your would be like your equation, right? So like on the left side, the power on the left side is gonna be this log, this left side of my equation, right? So this log in base 2 of x, and the power on the right side would be the right side of my equation here, which is x. Okay. So as you can see, guys, the thing, so this is a log, right? And this 2 here, this is an exponential base 2, right? Because remember, exponential, it's like some constant to some power of x. So this is an exponential here, and here this is a log. So then, because when you compose the exponential and the log, they're inverse of each other, so they cancel out. So this thing here, you cancel out. And you end up with just x. Sorry, it's not x here, it's 8, sorry. This is 8, right? I have 8 here. For some reason, I said x. It's log in base 2 of 8, of course. Right, so then you are left with 8. So here on the left side, you have 8, right? And on the right side, I have this 2 to the power x. Okay. Now, the question is, of course, so for which power of 2, 2 to the power x would be equal to 8? You know, because 8, this is equal to 2 power cube, right? 2 times 2 times 2. That would be 8, right? So 2 multiplied by itself 3 times would be 8. So as you can see here, guys, this is 2 cube, and on the right side we have 2 to the power x. So we have the same base, right? This is base 2 here. This is base 2. So if you have the same base, then the powers, they're going to be equal. So then your x is going to be equal to 3. Okay, so if you have same base, so yeah, same base, then the powers are equal. Then powers are equal. Okay, so then my x is equal to 3, and that will be the solution. Right.
So you put that 2 over there because that's the number you got. I mean,
which 2?
the number that multiplied itself by
the blue one here.
I'm talking the number 2 with the exponent 3 on the left.
Oh yeah,
of the
because
8.
no, yeah, just because 8 is, we can write 8 as 2 cubed. Yeah,
I see.
Professor, what are the two
Yes.
x? Hold on. When you cross out the log in two,
Yes.
you put do you always put the base on the other side with the x?
Oh, you mean this side here?
Yeah.
Oh, yeah, because so I am applying the same exponential both sides. So here I applied like exponential on base 2, so I have to apply the same thing here. That's in my exponential base 2, right? And what I'm saying is that now for the power, I'm gonna put like my equation. My equation was like log in base 2 of 8 equal to x, right? So
Yes.
here on the left side, I put like the left side of my equation, and here I put like the right side of the equation, which is just x.
Okay.
Okay, so I mean, like you have your equation here, so that would be like the powers of your exponential, and of course here I took exponential in base 2 because the base of the log it's 2, so the exponential and the log they have to be they have the same they must have the same base. All right. And as I said, there's another way to do it. So this, I mean, this trick applying the exponential, whenever we have, we'll see later, like we're gonna have like more complicated logarithmic equations, but we're gonna use always the same trick. We're gonna always apply the exponential to get rid of the log. I mean, that's like what we always do. Whenever we have log, it's kind of, as I said, log is really hard to, I mean, it's ugly, so get rid of it. And the way to do it is just apply the exponential. But there's another way to do it, to solve this problem, actually. So another way to do it is, so come on. So another way, solve. So we can use the properties we had. So remember, we had to solve, so x, we said it's log in base 2 of 8, right? And we want to find x. So what we can do first, as I said, the 8, it's 2 power cube, 2 cube. So I'm gonna write 8. So this is log in base 2. I'm gonna write 8 as 2 cube, right? Because 2 times 2 times 2, that would be 8. Now, so you see, guys, the last property here, like when you have a log in some base b of x to some power a, so if you have like some power inside the log, then you can move the power to the front of the log. Okay, so here I have this log of 2 cubed, so I have this power phi, right? This is the power phi here. So then I can move this, can put down this in front of the log. Okay, so that'll be like phi times log in base 2 of 2. Okay. And then log in base 2 of 2, that's like that's like log in base b of b, right? This is like the second property here. So a log in base b of b, that will be 1. So this log in base 2 of 2 would be 1. So this thing here, that will be equal to 1. Okay, so then the answer will be like 3 times 1, and that's 3. And of course, we get the same answer. So all I'm saying, guys, is sometimes you can use like these properties of the log, right? To find your x. But of course, it depends on the problem. Sometimes it doesn't work. But the trick which always work is the applying the exponential. Yes, Elizabeth.
Can you explain the last part, like 3, 4?
Yeah. Okay. So you agree that 8 is 2 cube, right? You agree that this 8 here, I can write 8 as 2 cube. right? That's 2 times 2 times 2, right? Now, what I'm saying is one of the properties of the log. So if you have a log, as you can see here, if you have a log of x to the power a, x to some power. So if you have a power inside the log, then you can always put down this power in front of the log. Okay, so this here we have this power 3. So I can move the 3, this power 3 to the front of the log. I can put it down here in front of the log. So that's why we have this 3 times log in base 2 of 2. Okay, and then log in base 2 of 2, that's like log in base b of b, that's equal to 1. So that's why I got 1 here, and then 3 times 1 would be just 3. Okay.
Thank you.
Mm-hmm. Okay, let's do more examples. So this is like first example, just I would say a very basic example. Now, things can get more complicated. So example number 2. So let's say you want to solve for x. Well, here I had just like one log, this first example, I had like a log, just one log, right? A log of 8 in base 2 is equal to x. So just one log. Now, let's say you have like 2 logs. Now, let's say you have like log in base, let's say 4 of x plus I'm gonna do an example. Let's do this one. So log in base 4 of x plus log in base 4 of let's say x plus y equal to 1. Okay. So this is different from the previous example because in the previous example we had just like one log, and because we have just one log, you can apply the exponential and you get rid of the log, right? Now I have like 2 logs, the sum of 2 logs, right? Log of this x in base 4 and this log of x plus 5. So I have 2 logs, right? This is the sum of 2 logs. Okay. Again, the idea is to get rid of this log, but the thing is, before getting rid of the log, I'm gonna try to combine these 2 logs in just one log. So in the first step, so in step 1, I'm gonna combine the 2 logs in just one log, Okay, and the way to do it is we're gonna use one of the properties. Remember when you have a sum of 2 logs, this is a property number 3. So we said, the property number 3. So we said if you have a log in base b of x plus, that's it, log in base b of y, that will be log in base b of x times y. Okay, this was the property number 3 for the log. Okay, so if you have a sum of the logs, then that will be the log of the product. Right? This is exactly this property here, number 3. This one here. So as you can see here, we have a log of the product, log of x times y. It's equal to the sum of the 2 logs, right? So that's exactly what I'm saying here. Okay, so I'm gonna try to use this property to combine these 2 logs, right? I have a sum here So be careful, guys, because there's a difference between a sum and subtraction. So in the case of the sum, so if you have the sum of two logs, then that will be, so if you have the sum of two logs, then what we are saying is that will be the log. You can combine the two logs in one log, and that will be the log of the product. So you have to multiply what's inside the log. So we have to multiply like this x by this x plus 5. Okay, so what I'm saying is that, so we start with this, log in base 4 of x. So this is my equation, right? Of x plus 5 equal to 1. And what I'm saying is that this would be, on the left side, this would be log in base 4 of x times x plus 5 equal to 1. Okay. So if you have a sum of the two logs, that will be the log of the product. So you multiply this x here by this x plus 5. Okay, so now I have like just one log instead of the sum of two logs.
What about those brackets?
No, yeah, that's what I'm saying. This is the brackets is just I mean, we are applying the log to this whole thing here. The bracket is just saying, I mean, instead of bracket, I can use parentheses here. It doesn't matter. But all I'm saying is that I'm applying the log to the whole expression, to the whole x times x plus 5. Yes. Is there a question in the chat? Yeah, for clarity, Lord. Yes. So, of course, again, guys, it's not log. It's not like log times x times x plus 5. This is log off. Okay, this is log of this whole thing, like the whole log of this x times x plus 5. Okay. All right, so I have now just one log of this whole thing, x times x plus 5. Now I can, in the next step, I can get rid of this log. So now in this step 2, so I'm gonna apply my ln trick, my exponential trick to get rid of the log. Okay, because so the base here, of course, is 4. It's log in base 4. So I'm gonna apply exponential in base 4 to both sides. So I'm gonna have like 4 on the left, 4 on the right. So we have my equation here. So on the left side, so as exponent, I'm gonna put this whole thing here, what I have here on the left side. That's the exponent of the left side. So we're gonna have like log in base 4 of this whole x plus 5. Sorry, x times x plus 5. All right. And on the right side, as exponent, I'm gonna put the right hand side of this, of my equation, which is just 1, right? So on the right side here as exponent, I'm gonna put 1. So don't forget, guys, to put so on the right side, you have to apply the exponential, right? I have an exponential here in base 4. So on the right side, I need an exponential in base 4, right? And then you put the right side as exponent. Okay, and here, that's what I did here. I put the left side as exponent. All right, so now I got, this is the exponential in base 4, and this is the log in base 4, so they cancel out. Okay, so it's just now x times this x plus 5 equal to 4. Of course, 4 power 1 is equal to 4, right? So, okay, now you see, I got rid of this log. Now things are getting better. because I mean, on the left side, it looks like it's a quadratic equation, right? If you multiply, I mean, if you distribute, you multiply x by x, that will be x squared. And there's a plus here, so here's my plus. And if you multiply x by 5, that will be plus 5x equal to 4. Right? Now, what I can do, I mean, this looks like a quadratic equation, right? So I'm going to just move the 4 to the left and then use my quadratic formula. So I'm going to subtract 4 both sides. So now I have like x squared plus 5x minus 4 equal to 0. Okay, and that's great because I know how to solve this, right? This is just, we can use the quadratic formula. Oops. So we can use a quadratic formula. So this is x would be minus b. So it's like minus 5 plus or minus, you know, square root of b squared. That's 5 squared. That's 25 minus 4 times a, which is 1, times c, which is negative 4, over 2a. So 2 times 1. All right. So then x would be minus 5 plus or minus. So 25, so minus minus here 4, that would be a plus. This minus minus would be a plus. So that's 25 plus 16. Right, that's 41. Yes. Is there a question in the chat? I saw something in the chat. Oh, yes, yes. Yeah, you want to get rid of the log before starting the problem. That's, yeah, exactly. And if you have like more than one log, you need to try to combine all the logs like this, just in the same log. If you have like sum of logs, you can write it like a log of the product, or if you have like a difference between two logs, you can write like log of the quotient, etc. Oh, Natalie, okay, I got you, thank you. All right, and then so this is, well, this is not a perfect square. This is a square root of 41. I think I picked the wrong numbers here, but anyway, it's the 25 plus 16, which is of course 41, which is not perfect square. Well, I mean, it's fine. It's not. I mean, you can, if you use a calculator, you can try to, you know, approximate the square root of 41, which is probably, well, between 6 and 7. Okay, so let's say it's 6 point something, 6.5 something. Okay, but I mean, it's not. I mean, it's not really important. You can just keep the square root of 41 in the test, or of course in the final. I'm gonna try to make sure that you get like a perfect square, right? Anyway, so then we have two answers. So we have two answers. So we have this x minus 5, let's say plus this square root of 41 over 2, which is approximately, I think, I mean, if you use a calculator, I mean, you don't have to use a calculator, and like in the final, it's for some reason you get like some like a square root, which is not a perfect square. You know, you don't have to find exactly the, you know, the value of x. Okay, I'm just trying to explain here you know, the solutions. So here would be like, I would say, if you use a calculator, that would be probably like 0.7 or something. Okay, and this is approximately. Okay,
You have to get that.
No. I'm just trying
put
to
in the two answers, it will be enough.
Yeah, no. So the answer, your answer should be this one here. You can stop here. That's the answer.
All right.
I'm just trying to, you know, I mean, for some people, they have like a trouble with the square root or decimal. I'm just trying to explain what will be this number. So, and the other answer will be, of course, this x, which is negative 5 plus this is square root of 41 over 2, which is again approximately probably 5 point something. Sorry, not 5. This is minus here.
If we put -5 plus minus a square root of 41/2, would that be good? I mean, or we have to separate it like you just did.
No. You don't have to separate it. No, you don't have to.
All right.
No, you don't have to. So yeah, this would be negative actually. This would be probably -5.6 or something, approximately. Okay. So yeah, here's the answers. Okay. Actually, we are not done yet. This is like the possible answers. So here we have there is another step. So that will be the step number 3. Okay. So in the step number 3, okay, so we need to check if the solutions are actually well defined. Okay, so you might ask, what's the problem here? So remember, guys, we had to solve this, log, where is it? Log in base 4. So the original question was like log in base 4 of x. We have this log in base 4 of x plus log in base 4 of x plus 5 equal to 1. And remember what I said, guys, when I discussed the log. Log is only defined for positive numbers. Oh, yeah. You mean the final? Yeah, it's going to be in the final, of course. This is going to be in the final. Yeah, in the final, as I said, the final cover the polynomials, the rational, the inequalities, and also this log and exponential equations. Yeah. And actually, homework number 6, there are some problems about this. Yeah, so what I said, guys, is that log is only defined for positive numbers. So you cannot have negative. So we cannot have negative or 0 inside the log. We cannot have negative or 0 inside the log. Inside the log. So this is like, like for the square root. For the square root, we cannot have negative numbers in the square root, right? Same thing for the log. We cannot have negative numbers and 0 inside the log. Okay, log is only defined for positive numbers. So inside the log. So what I'm saying is that inside the log, so here inside the log I have x, and here inside the log I have x plus 5. So we need to make sure that this x and this x plus 5 are positive when x is equal to my solution, right? I got 2 solutions here, right? And I need to make sure that this x and this x plus 5 are positive when x is equal to the solution. Okay, so make sure that x, we need to make sure that x, that's x is inside my first log, and not just the first log. I have another log, and the x plus 5 are positive. X plus 5. The x plus 5 is inside my second log, right? So I have x inside my first log. I have x plus 5 inside my second log. I need to make sure that both of them are positive when x is equal to the solution. Are positive when x is equal to one of the solution. Right, I got 2 solutions, right? I got 2 possible solutions actually. So that is this -5 plus square root of 41/2, which is, we said, approximately 0.7, and the second solution, which is approximately negative 5.6. So so let's say when x is equal to my first solution. So when x is equal to my first solution, so my first solution is this -5 plus square root of 41 over 2, which is again approximately, we said it's like 0.7. Then, well, x is obviously positive, and x plus 5 is also positive. Then x, which is 0.7, and x plus 5, which is like 0.7 plus 5. So both are positive. Both are positive. So this is a real solution. So this is actually a real solution of the problem. This -5 plus the square root of 41 over 2. Because when I take x or I take x plus 5, they're gonna be both positive. Now, what about the other solution? The other solution is this when x is -5 minus square root of 41 over 2, which is, we said, approximately -5.6 or 7, something, 0.6, I think. Then x is -5.6. Well, that's negative, and the other one is also negative. But anyway, if one of them is negative, then you are done. You have to reject the solution because it's not possible to have a negative number inside the log. So both x and x plus 5, which is minus like 5.6 plus 5. So that would be like minus 0.6. So both are negative. Both are negative. So this solution is rejected. So we have to reject. So then x, which is -5 minus square root of 41 over 2, is rejected. That's not the solution. That's not a real solution of the problem. So find the answer. There is actually one true solution of this equation, which is there is only one solution, which is this x equal to -5 plus square root of 41 over 2. And the other one is not a real solution of the problem. So you see, guys, there is this condition that when inside the log, it must be positive. So when you have your solutions, you have to make sure that when x is equal to your solution, what's inside the log is going to be positive. So here, as you can see, both of them are negative, right? I got this -5.6 and I got this -0.6. So both of them are negative. But if just one of them is negative, let's say here I got plus. For some reason, I got like plus here instead of a minus. But still, I have this one here, it's negative, then we have to reject the solution, okay? So if one of them is negative, then it's rejected. So both of them must be positive. Okay. Any question, guys?
Yeah, I have a question. I'm sorry.
Mm-hmm. Yeah,
You
sure.
said if both of them are negative, it's automatically rejected, right?
Yeah, even if one of them, just one
Yeah,
of them
that
is
was gonna be my next
negative,
question. If one is negative, it's still rejected.
it's still, yeah, it's still
Okay.
rejected. Yeah.
All right, perfect.
All right. Is there any other question, guys? But you see the idea here. So whenever you have like sum of two logs, so the first step would be to, as you can see here, the first step would be to combine the two logs in one log. Second step, get rid of the log by applying the exponential, and you're gonna get some equation, some polynomial like quadratic equation or something. You solve your quadratic equation, and then the last step. This is really important, guys. I mean, if you don't do this last step to check if your solutions are well defined in the final, you won't get full credits, okay? Because again, that's like by definition, the log must be applied only on positive numbers. So if you just skip this last step, you won't get full credit All right, so let's do one more example, and then I'll give you an exercise. Now, so the next example I'm gonna do, I'm gonna subtract 2 logs. Example 3. Now, let's say I have log in base 2 of x plus 1 minus, so this is minus log in base 2 of x plus 2 equal to 2. Okay, and of course we need to solve for x. So this is different from the previous example because here we have a subtraction, we have a difference between 2 logs. In the previous example, it was like plus, so it was a sum of 2 logs, right? The previous, where is it? Right here, here. So as you can see, in the previous example, we had the sum of 2 logs. Right now, let's say we have the difference between 2 logs. So if you have the difference between 2 logs, then we're gonna use another property, which says the following. So because this is minus, so I'm gonna just remind you. So if you have a log of difference between 2 logs, so if you have like log, this is property number 4. If you have log in base b of x minus log in base b of y, that will be log in base b, not x times y, but x over y. Okay, so this is different, right? Again, minus, it's x over y. Okay, so make sure that you so memorize this. Anyway, so so let me write down again my equation. So my equation was like log in base 2 of x plus 1 minus this log in base 2 of x plus 2 equal to 2, right? So as a first step, guys, we're gonna have the same first step. So we're gonna try to combine these 2 logs in just 1 log using this property number 4. And then once you have 1 log, again, apply the exponential, get rid of the log, and then you're gonna end up with some kind of simple equation, all right, without logs. So so step 1. So I'm gonna combine the 2 logs. Combine the logs in 1 log. So what I'm gonna do, so as I said, so if you have log of x minus log of y, of course, in the same base, there'll be the log of x over y, right? So here I have like x plus 1, log of x plus 1, minus the log of this x plus 2, right? Then there'll be the log of x plus 1 over x plus 2. Okay, so so we're gonna have log now in base 2 of, and as I said, so you're gonna use this property number 4. So we're gonna have the first term here, which is x plus 1. So we're gonna have x plus 1 in the top divided by, and the term in the second log is x plus 2. So here divided by x plus 2, right? And the right side is just the same thing, just stays the same thing. So yeah, so here I'm saying log of the difference between the 2 logs, that will be the log of the quotient, the x plus 1 over the x plus 2. So now I got just 1 log, right? And so then I can move to the next step. So step number 2, which is again the same step as the previous example. I get rid of the log by applying exponential. Exponential. So this is log in base 2. All right, so here's my exponential in base 2. Here's my exponential in base 2, right? And in the top as exponent. So I'm gonna put the left side of this equation here, which is log in base 2 of x plus 1 over x plus 2. And on the right side, it's 2. So that's why we have 2 here, okay? Because on the right side I have 2. It doesn't, I mean, it's not because I have because the base is 2. because the right side is 2. That's why I have 2 here as exponent, right? Okay, now, so now I can cancel out this log here and this exponential on base 2. So now I have like x plus 1 over x plus 2, just x plus 1 over x plus 2, right? And on the right side, it's 2 squared, which is 4. So you see, it's kind of different from the previous example, because like in the previous example, we end up with like a quadratic equation, right? But here it's like, equation between 2 fractions, right? And now how do we solve this for x? Well, I mean, we did this like for when we try to find like the inverse of a function, right? So there's an x in the top and x in the bottom here. So we need to move the x to the top, all the x's to the top. So the way to do it, of course, would be to make this 4 look like a fraction. So just divide by 1 and then cross multiply. So we're gonna cross multiply, right? So that would be like 1 times x plus 1 equal to, on the right side, it's 4 times x plus 2. Okay, so that would be x plus 1 on the left, and on the right, it's 4 times x plus 4 times 2, which is 8. All right. Well, I have to move all the x's on one side and all the constant to the other side, right? So, well, you can, for example, subtract, let's say, x here. I'm going to subtract x here. So there'll be 1 on the left. 4x minus x, that will be 3x. And plus 8. Right? And then you can subtract. We want to solve for x, right? So subtract this 8 from both sides. So on the right side, I'm going to have 3x, and on the left, it's going to be -7. And now, final thing to do, of course, this is 3 times x. The opposite operation would be division, so we have to divide by 3, both sides. And so final answer would be x equal to -7 over 3. Okay. That's, excuse me?
Sorry, I have a question.
Yes, please.
Okay, with the log minus a log, means log x over y.
Yes.
That's for exponents, right? Because when you're dividing a numbers with exponents, you subtract the exponents, right?
Oh, yeah.
But
Yeah.
yeah, but you see in the parentheses, those aren't exponents. Those isn't that the answer to the base with the exponent, the number in the parentheses.
Which number? This one here?
Yeah.
Which number? The x plus 1 over x plus 2?
Yeah, yeah, good. Yeah, because 2 is the base, the one in the parentheses is the answer, and equal the number after
Yeah. So
is the exponent, right?
yeah. So well, I mean, how I got this x plus 1 over x plus 2? That's because because this is like here. This is like x, and this is like y. This whole thing is like x, and this whole thing is like y. So if you have the difference between 2 logs, so then there'll be like log of x over y, right? That's what we said here. So that's like my, yeah, go ahead.
I'm sorry. Yeah. It's just that I thought that applies to the exponents.
No. So the exponent, no, later. So once once you have this step here, so this is like, so this whole thing is like x, and this whole thing like it's like y.
Okay.
So then that would be like log of x over like the log of y.
Okay.
Sorry, log of x over y. And then the next step, that's where you apply this exponential. It's the same base. And then as exponent, you put like your equation, right? This is like you know, this is like the two sides of my equation, right? That's my exponent. Right, and we are not done yet, guys, because as I said, there's the last step where you have to check if your solution is well defined. So check if the solution is well defined. So in this case, is well defined. So what's my equation here? So just to remind you, we had like log in base 2 of x plus 1 minus log in base 2 of x plus 2, right? Equal to 2. So what's inside the logs? Inside the logs, I have x plus 1. And inside the other log, I have x plus 2. So when x is my solution is equal to my solution, I have to make sure that these two terms, the x plus 1 and x plus 2, are positive. Okay, so when x, so when x is equal to my solution, which is -7/3, right? That's my solution. I need to make sure that x plus 1, this x plus 1 is positive, and this x plus 2 is also positive. So you can see here, guys, so if you do x plus 1, so x plus 1 would be like -7/3 plus 1, which is, I mean, if you take a common denominator, it'll be 3/3. So that will be a -4/3. So this is negative. The other one, x plus 2, that would be -7/3 plus 1. So that's -7/3 plus 6/3. And that's -1/3. So anyway, so both of them actually are negative.
Plus 2, right?
So we have to reject this solution. So this x, so both are negative. But anyway, as I said, if just one of them is negative, then still you have to reject the solution. So so we have to reject, so x equal to -7/3 is rejected. Okay, and your final answer is there is no solution. Okay, so as you can see, guys, I mean, this last step is kind of I mean, it makes difference, right? I mean, you see, we end up with no solution. We thought we have a solution, but actually we don't, right? Is there any question, guys? All right, so here's an exercise for you. So this is very similar to the problem. I think someone asked me about the first problem in the homework 6, which is the last homework of the semester, not the semester, but I mean this of our class. So the problem 1, as you can see in the problem 1 in the homework number 6, which is due Thursday night. So we have like 2 log equations, and so they are very similar to our the examples we had, right? And here's an exercise. So please try to solve for x. So 1, so let's say we have the log of, so log in base 5 of x minus 4 minus log in base 5 of x plus 3 equal to 1. Number 2. So let's say you have log in base 2 of x minus 1 plus log in base 2 of x, let's say x plus 3 equal to 2. All right, guys. Yeah, so please try to solve these 2 equations. So this is like a problem one. The first two equations in problem one in the homework 6. This is like problem one in homework 6. So let's say you have 10 minutes, guys, to think about this exercise. And again, so this is going to be in the final for sure. They're going to have a question where you have to solve logarithmic equations, right? This is in the final. I mean, probably the same equations, but just different numbers. And after the log, guys, we're gonna try to solve exponential. I think exponential equations are easier than the log. Well, depends, of course, but I think in general they're easier to solve. All right. The formula for the bottom. Oh yeah, sure. So so this is like log n base b of x plus log n base b of y. So that'll be log n base b of x times y. And if you have a difference, that will be log n base b of x over y. Sure. So I guess I would try to grade the final guys on Friday with the homework number 6. So hopefully, like Monday next week, you can find your grade on CUNY first. Sean, you're saying yes. I think you're right. Yes. Yeah, Lord and Lisbeth, I think there will be no solution for number 1. Yes. That's very good. Yes, no value of x makes this equation true. Absolutely, yeah. Yeah. I mean, what you have to keep in mind, guys, is this log is just the inverse of the exponential. I mean, don't be scared from the log. I know a lot of students, they get very confused about this log, but it's not. It's just it's just a formal formal. It's just a formal definition. So it's just the inverse of this exponential function. So any guess for number 2? Elizabeth. Well, I think you guys, you have the same answer. -1 plus 2 square root of 2. Yes, I think that's correct. Yes. So yeah, in the final, guys, again, well, here I didn't probably pick the right numbers, but in the final, I'm gonna make sure that you have, like, if you have a square root, I'm gonna make sure that you have like a perfect square. I don't want you like to end up with some square root. So yeah, Lord and Elizabeth, I think you are correct, guys. All right. Does anyone need more time? Okay, probably not. So let me go over this, and I don't know if we're gonna finish this before the break or not, but the plan is after this, we're gonna do some exponential equations, which I think easier than the logarithmic equations. And then we're gonna do like a little bit of trigonometry. Okay, so for number 1, so we have this log in base 5, x minus 4, minus this log in base 5 of x plus 3 equal to positive 1. This is positive 1, so step 1. So I'm gonna use my formula, so I'm gonna combine these 2 logs into 1 log. So that will be log in base 5 of, well, because it's a minus, again, you have to be careful, guys, this is a minus, so that will be like my x in here, this thing here, over the y here, which is this x plus 3. All right, so that will be x minus 4 over x plus 3 equal to 1. Now, in the step 2, I'm gonna apply, step 2, I'm gonna apply my exponential to get rid of the log. So apply exponential. Okay, so here the base is, of course, it's the basis of 5. So the base is 5, as you can see. So we're gonna have 5 base 5, and as exponent, I'm gonna put my equation. So on the left side, we have this log in base 5 of this x minus 4 over x plus 3, and on the right side, it's 1. Okay, and then as usual, this log and this exponential, I cancel out. So this is just x minus 4 over x plus 3 equal to 5. I mean, 5 power 1, of course, it's obviously 5. Now I'm gonna divide 5 by 1 and then cross multiply. So that'll be 5, sorry, So that would be 5 times x plus 3 equal to 1 times x minus 4. Okay, so if you distribute, so 5 times x, that's 5x, is a plus. So here's my plus, 5 times 3, that's 15. And on the right side is just 1 times x minus 4, so it's going to be just x minus 4. All right, so now I'm going to move all the x's on the left side and the constant to the right side. So I'm going to subtract x. So it's 5x minus x, it's 4x now, plus 15. And on the right side, it's just negative 4 because this x cancels out. Now, on the left, I have 4x plus 15. So I'm going to move the 15 to the right side. So I'm going to subtract 15 because it's a plus 15. So I'll subtract 15, the opposite operation. So that would be 4x now on the left. This 15 goes away. And on the right side, it's minus 4, minus 15. That's negative 19. And as you said, guys, and I think Sean said, so this is just divide by 4 sides. So then this is x equal to negative 19 over 4. So this is my possible solution of the problem. Now, in the last step, I need to make sure that this solution is well defined. So make sure that x minus 4 and x plus 3 are positive. So step 3. So we have to check if the solution is well defined. Fine. So that's x minus 3. So that's like negative 19 over 4 minus 3. Common denominator. So negative 19 over 4 minus 12 over 4. 12 over 4 is 3. So that's negative 20, not 20, but 31 over 4. And that's negative. So you don't have to check the x plus 4 because, as I said, if one of them is negative, then the solution is rejected, right? So this is negative. So x equal to a negative 19 over 4 is rejected. Okay, because x minus 3 is, when x is equal to my solution, x minus 3 is going to be negative. And inside the log, we cannot have like negative numbers. So there is no, so your final answer should be no solution. Is there any question, guys, about this? For the next one, it's a sum of two logs. So we have this log of in base 2 of x minus 1 and x plus 3. So for number 2, so log in base 2 of x minus 1 plus log in base 2 of x plus 3 equal to, if I'm not mistaken, well, I'm not sure actually, it's equal to, where is it? Yeah, equal to 2, right? This is equal to 2. All right. Yeah, thank you, Rodden. So for step 1, so we're going to use our formula. So we're going to combine these two logs. And now, because this is a plus, right, then we're going to multiply the x minus 1 by the x plus 3. So it's going to be log in base 2 of x minus 1 times x plus 3. So again, because of plus, it's a product, it's multiplication here. and this is equal to 2. Now, as next step, get rid of this log, apply exponential. So the base is 2. So here's my base, 2, both sides. And then on the right, on the left side, so in the exponent, I'm gonna have my the left side of my equation. So that's log in base 2 of x minus 1 times the x plus 3. All right, and on the right side as exponent, I'm gonna have the right side of my equation, which is 2. Right, and then, so again, guys, what I did here is that I put like as exponent the left side of my equation, right? On the left, and on the right, I put my the right side of my equation as exponent. All right, then we end up with now on the left, it's just x minus 1 times x plus 3 equal to 2 power 2. So 2 squared, that will be 4. All right, so now it's going to be a quadratic equation, right? We're going to just distribute. So x times x would be x squared plus 3x. And then there's this minus 1 times x, so it's minus x. And there's minus 1 times plus 3. That will be minus times plus, that will be minus. So that's minus 3 equal to 4. All right. And well, I'm going to just subtract 4. So then I can have like just like a quadratic equation. So on the left I have like x squared, and here as you can see plus 3x minus x, that will be plus 2x. So this is plus 2x, and then minus 3 minus 4, that's minus 7, equal to 4 minus 4, of course. 4 minus 4 is just 0. Right, so now I have this quadratic equation. I can solve this using quadratic formula. So this is x minus b, so minus 2, plus or minus b squared, that's 2 squared, so that'll be 4, minus 4 times a, which is 1, times c, which is negative 7, over 2a, which is 2 times 1. This is negative 7, of course. So minus minus inside the square root here, that will be a plus. And so that will be square root of 4 plus 28, that will be 32. So my x, it's actually minus 2 plus square root of 32 over 2. Okay. Now square root of 32, guys. I mean 32, you can write like 8 times 4. So there'll be like, so the 32, you can write it like yes, 16 over times 2, exactly, Sean. So this is 32. 32 is 16 times 2. So when you do the square root of 32, that will be square root of 16 times square root of 2. So square root of 32 is just square root of 16. You can split here the square root because you have like a multiplication. So you can split. So that would be the square root of 16 times the square root of 2. Now square root of 16, that's 4. I mean 4 times 4 is 16. So the square root of 16 is 4. So this is like 4 times square root of 2. Okay. So what I'm saying is that this square root of 32 is just 4 times. We can write it like, so this is x minus 2 plus 4 times square root of 2 over 2. I think this is kind of a common mistake. So here, guys, when you divide by 2, we have to divide each of the terms by 2. So it's like we divide the 2 by 2, right? And also the 4 by 2. Okay, so this is like, this is like minus 2 over 2 plus the 4 square root of 2 over 2. Plus or minus, sorry, here I forgot plus or minus. I missed something in the chat. Yes, Lorden, absolutely. So then x would be, so minus 1 plus or minus, so 4 over 2, that would be 2, so 2 square root of 2. So we have two possible solutions, right? A -1 or -1 plus or minus 2 square root of 2. Now, we have the last step, so we have to check phi, check if solutions well defined. Okay, so first we have inside the logs, we have x minus 3 and sorry, x minus 1 and x plus 3, right? So inside the log, so just to remind you, so we have like log in base 2 of x minus 1 plus log in base 2 of x plus 3 equal to 2, right? So inside the log, we have x minus 1 and we have x plus 3. So when x is equal to my solution, so let's say when x equal to, my first solution is, let's say -1 plus 2 square root of 2, right? That's my first solution. Then, so if you subtract 1, then x minus 1, so that would be like minus or -1 plus 2 square root of 2 minus 2. So that would be equal to -2 plus 2 times square root of 2. Okay, now, so the question is this positive or negative? Well, actually, square root of 2 is approximately like 1.7. I mean, if you use a calculator, this is like approximately 1.7. So, so this -2 plus 2 square root of 2 is going to be positive. Okay, this is positive. This is positive. And of course, if you do x plus 3, which is, so x is -1, you know, plus 2 square root of 2, plus 3, that will be plus 2, plus 2 square root of 2, which is obviously positive. Is positive. Okay, so this is actually a true solution of the problem or of the equation. Okay. Now, the other solution when we have minus, so when x is -1 minus 2 square root of 2, then if you do x minus 1, so there'll be like a -1 minus 2 square root of 2 minus 1, so there'll be like -2 minus 2 square root of 2. And this is obviously negative because -2 is negative, and then you subtract this 2 square root of 2, it's also negative. So, so this thing is going to be negative, and so then the solution is rejected. So x equal to -1 minus 2 square root of 2 is, so this is rejected. Okay, so I end up with one final solution of the problem, which is the -1 plus 2 square root of 2. So the answer here, so x equal to -1 plus 2 square root of 2 is the solution of the equation. Okay. Any question, guys? Okay, I guess there are no questions. Well, we have like 9 minutes before the break. So I probably gonna do the exponential equations after the break. I think it's better. I'm gonna just say one more, I'm gonna just discuss one more example about this logarithmic equations. I mean, things that can get like very crazy. So for example, I'm just giving you an example here. So let's say you have like log in base 2 of x minus 1 plus like log in base 2 of, I don't know, let's say x plus 3 equal to log in base 2 again of x plus 4 and a minus, or I mean, minus log in base 2 of let's say x, just x. Okay, so you're gonna have like more than 2 logs. You can have like 3 logs or 4 logs. As I said, things can get very crazy. But the idea is always the same, right? So you need to combine the logs, you need to get rid of the logs, and then just solve your equation, right? So for example, here, I would just, as a first step, I would just combine the logs. Like on the left, there'll be log in base 2 of, x minus 1 times the x plus 3, right? And on the right side, there'll be log in base 2 of, because it's a minus, so we're going to have like x plus 4 over x. Okay. And then you can apply exponential to get rid of the log from both sides. So like in step number 2, you can have like, so the base is 2, of course. It's the same base here. So I'm going to use base 2 here. Here's equal. So here I'm going to have like log in base 2 of this, x minus 1 times x plus 3. And here it's like log in base 2 of x plus 4 over x. And then, so this cancel out. So it's just x minus 1 times x plus 3 equal to, x plus 4 over x, for example. Okay, and then you can try, of course, now you got rid of the log, so now it's just like you can try to solve this equation. It's going to be just some polynomial equation. So for example, here you can you can multiply both sides by x, and then you can multiply this thing here by x and this thing here by x. So then we get rid of this x here. So, and then just and then you can just try to solve. We're gonna have some polynomial equal to 0, and you try to factorize your polynomial to find your solutions. Okay. Anyway, so all I'm saying here, guys, is that in the log equation, you can have like 3 or 4 or 5 logs, etc. But as I said, the idea is the same. First thing to do is try to combine all the logs like in the same log. Once you have like just a log with the same base, this is really important. You need the same base, right? And then you apply the exponential, get rid of the log, and then you end up with some, just some polynomial, quadratic equation, or like some polynomial equation, and then try to factorize, etc., to find the solutions of the equation. Anyway, I think next, as I said, next would be the exponential equations. I think they are easier than the logarithmic equations. But let's take a break because I think it's better to start this exponential equations after the break, right? Not next time, sorry. After the break, I mean. So after the break, so after the break, we're going to discuss exponential equations. All right. So for probably this is the first time I'm going to have a break before 8 p.m. It happens sometimes. So I'll be back. So 1956. Oh, Tiffany. No, don't come back tomorrow. No, no. I said I'm going to come back tomorrow. Well, I'm sorry. Okay.